All right, guys, today we're going to learn about factoring polynomials. This is just the first day. And so we're going to kind of review some topics you did in quadratics and then put it all together. So first, we want to talk about what it means to be a factor. And if a number is divided by any of its factors, the remainder is always 0. That's true of all the numbers, like for example, like 12, right? What are the factors of 12? Well, you've got 2 and 6 and 3 and 4 and 1 and 12. And if I divided by 12 by any of these numbers, there'd be nothing left over. So the same is true for polynomials. So here, for the first couple of problems, we're just checking to see, is x minus 3 a factor of p of x in this case, which is x squared plus 2x minus 3. So we want to know, is this a factor? Now, obviously, we can factor p of x. It's pretty straightforward. But let's say it was something more challenging, right? We could use this division idea to check to see whether or not something was, in fact, a factor. And we do that pretty easily. We just be doing some division, right? So most of you by this point in time, I'm guessing, prefer synthetic division. So hopefully you know, from this x minus 3 factor, we'd be putting positive 3 inside this box. And then the coefficients of the polynomial. Oh, that's a negative 3 on the end. And then going ahead and doing our synthetic division. So we'd bring down our 1, multiply it by 3, add them up, get 8, and then we'd have 5 left over. This is our remainder. So that meant that x minus 3 didn't go into x squared plus 2x minus 3 because the remainder was not 0. So this is not a factor. But let's say we go ahead and try the next one, right? We're going to have x plus 4. Check to see if it's a factor of this polynomial over here. So we'd put in negative 4. And then we do our synthetic division. Don't forget to add in the 0 because we're missing an x squared term and a 2 and an 8. And then go ahead, we're going to check out to see whether or not negative 4 works. And that becomes 0. That's 0. And so then we have another 2. And then we get negative 8. And then this 0 is our remainder. So yeah, this is a factor. X plus 4 is a factor of this other polynomial. So if you go ahead and try that below on the 2 below, after the fact, you can go ahead and check your answers on the OneNote. All right, so now that we know if something is a factor, and we will use that fact, we'll kind of work on that. Let's talk about what it means to factor, right? And factoring that you've already spent a ton of time on in Algebra 1 with factoring trinomials. It's a way of rewriting a trinomial in another format, meaning its factors, without changing the actual terms. So factoring, you should always be able to re-multiply out your answer and get the original thing you started with. And if you aren't getting the original thing, then you got to check your factoring. I think some of us very frequently don't check our factoring. So here we've got x squared plus 5x plus 6. And if I wanted to rewrite it, I'd be looking for numbers that multiply to 6 and add up to 5. That's what you learned in Algebra 1. And so I think everyone would say that would probably be x plus 2 and x plus 3. And that's great because if we were to remultiply this, we would get x squared plus 2x plus 3x plus 6. Which is, in fact, x squared plus 5x plus 6. So keep that in mind as we're going through these problems because you should be able to remultiply any of them at any point in time and end up right where you started. Okay, so and before we start our first one, we're going to do 2 types of factoring today. Factoring by grouping. I'm going to remind you of something that you learned a long time ago. Well, not a long time ago, but when you did factoring with Mr. Bound, difference of squares factoring. And so in difference of squares factoring, right, you were started with these 2 perfect squares. We usually write it as a squared minus b squared. And it has to be a difference. It only works if there's subtraction. That's really important. And they both have to be perfect squares. So we're talking, 1, 4, 9, 16, those types of numbers, perfect squares. And they would always factor into this pattern, a plus b, a minus b, or a minus b, a plus b. You could write it the opposite way around. So we would factor things like x squared minus 4. These would both be perfect squares. And so we'd say, oh, well, that's like x minus 2 and x plus 2, or x plus 2, x minus 2. And x squared minus 100 would be x minus 10, x plus 10. And x squared minus 25 would be x minus 5, x plus 5. And then finally, we can get a little more fancy. This could be a perfect square as well, 9x squared. And so that could be 3x minus 4 and 3x plus 4. All right, so I remind you of that because sometimes at the end of our factoring by grouping, one of our terms is actually still a difference of squares. And so that's kind of important to keep in mind because we're not done factoring until we have factored everything. Factor further, always. All right, so let's do factoring by grouping. Here I have 4 terms. Factoring by grouping usually works if you have an even number of terms. And you can group, in groups of 2 or groups of 3. It kind of depends on how many you're looking at. So most of the time, you're going to see us looking at 4 terms. So here we've got x cubed plus 3x squared minus 4x minus 12. And we're going to group the first 2 terms and the last 2 terms, kind of just naturally. Technically, you can reorganize things. Sometimes you'll even group the first and the last, but not really. For you guys, we'll mostly just do the first 2 and the last 2. The first 2 terms, you look at them and you say, all right, what do they have in common? What is their common factor? And x cubed and 3x squared both have x squared in common. So you're going to take that out of the first 2 terms. You're going to factor it out. And you're going to be like, all right, well, if I take x squared out of x cubed, I'm left with x. If I take it out of 3x squared, I'm left with positive 3. The second 2 terms, you're trying to make, you're trying to find their greatest common factor as well. But sometimes you'll need to take a negative or something because what you're trying to do, you'll see it in a second. If I look at negative 4x and negative 12, hopefully you're saying negative 4 is what they have in common. And what we're trying to make happen is we're trying to make these parentheses be the same. So it is, if you take out the negative 4 from the 4x, you're left with x. If you take out the negative 4 from the 12, you're left with positive 3. And these 2 match, which is super important. Because what we're now going to do is we're going to factor these parentheses out of the expression. And you're like, all right, well, now I've got x plus 3 over here. And what's left over inside the parentheses? Well, from this term, I was left with an x squared. And from this term, I was left with a negative 4. So I get x plus 3, x squared minus 4. And you might think you're done. And you're like, oh, I'm done. But remember my warning that if anything is left in the parentheses that can be factored further, you must do it. And this x squared minus 4 is a difference of squares. So we have to take that one a little bit further. We still have our x plus 3, and now it can be x plus 2, x minus 2. All right, so go ahead and try the next 2. And then, as I said again, afterwards you can check your answers on the OneNote. All right, our last type of factoring for today is another special type of factoring is the sum and difference of cubes. Notice we're talking about cubes. And also, it's like the difference of squares, except we're saying it also works for the sum as well. And they have these 2 fancy little formulas that I'm going to help you memorize in a second. So first, we need to remind ourselves what exactly are cubes, right? Cubes are numbers that you raise to the 3rd power. So, for example, 1 cubed is just 1. So 1's a perfect cube. 2 cubed is 8. 3 cubed is 27. 4 cubed, hopefully you know this one, is 64. 5 cubed is 125. And then there's a bunch of others which we'll explore a little bit later on. But right now we can go up to 10 cubed, and 10 cubed is 1,000. Right, so those ones you should be pretty commonly able to recognize. So the deal with the sum and difference of cubes, it has a pattern, as you see right up here. I've written out the formulas for you. And it's kind of similar with the A's and the B's to the difference of squares. But it's a little bit more complicated. So basically, we're trying to identify what is being cubed, right? For each of them, we've got something being cubed. And you cannot mistake this for the raising a binomial to the 3rd power, right? This is not the same In fact, I'm going to write it up here. X plus 1 cubed does not mean x cubed plus 1 cubed. They are not equal to each other, right? You cannot distribute that cube to the sum. So here we're saying, all right, so something is being cubed and something else is being cubed, and they're either added or subtracted to each other. And what happens is they get in these two parentheses. And so we take the cube root, we figure out what is being cubed for the a and the b, and we fill them in this pattern. The first equation, they're going to be a and b. And the next one, they're going to be a squared, ab, and then b squared. And then I have a little acronym to remember that the signs are the same sign as the one that you started with, the opposite sign, and then the last sign is always positive, right? So if it starts as a subtraction, this will be a subtraction, then an addition, and then an always positive at the end. And if it started with an addition, it would be addition, and then subtraction, and then always positive at the end. All right, so let me give you an example of that, a couple of examples. So the first one here, 8y cubed minus 27. Right, we're saying, okay, what am I cubing to get 8y cubed? What cubed gives me 8y cubed? And so we're cubing something to get the 8, we're cubing a 2, and we're cubing a y. So a is 2y. And then we're asking ourselves, all right, well, what cubed is giving me negative 27? Right, so we're saying, all right, something cubed gives me negative 27. And that would be negative 3. So b must be negative 3. So then we're going to fill it in our pattern. So we're going to fill in the a, 2y, the b, negative 3. Oh, hold on a second. And actually, I'm gonna ignore the negative for a little bit, but you'll see it actually kind of would have worked anyway, right? So we're gonna just say what cube gave me 27, and the answer is just 3. So we're gonna fill in just the 3, and then we're gonna say a squared. So I'm gonna take my 2y and I'm gonna square the whole thing. Then the next term is ab, so I'm gonna multiply the two of those, which gives me 6y. And then the last thing is I'm going to square the b, so I'm going to square 3, which is 9. And then I have to fill in my signs, same, opposite, always positive. So the same sign would be a negative. The opposite would be addition. And then always positive would be a plus on the end. So finally, the only thing we could do is we can actually square out this 2y. So it would be 2y minus 3 times 4y squared plus 6y plus 9. And that would be the factoring of that difference of cubes. All right, my last example. You might look at this one, you might be like, well, these don't look like cubes, right? 5x to the 4th plus 40x. But don't forget about greatest common factor, the first line of factoring. So what do they have in common? They have a 5 in common and an x in common. And if I take that out, I end up with 5x times x cubed plus 8. Well, now, hopefully it's not too hard to see that this is a perfect cube, right? A is x, it's a perfect cube. And b, what am I cubing to get 8? B must be 2. So my 5x is still super important. I'm going to bring it along, and I'm going to write out my parentheses. I've got a, b, a squared, ab, and b squared. 2 squared. And so then I can fill in my signs. Same sign, opposite sign, always positive. So then this finally comes out to be 5x times x plus 2 times x squared minus 2x plus 4. Now you might be wondering about this trinomial in the end. For you guys, this trinomial will not be factorable. So you will always be you won't be trying to factor that last trinomial, the x squared minus 2x plus 4. All right, so go ahead and try the rest of the problems on the practice sheet, right? You can see them all here. And then go ahead and check the OneNote afterwards, and you can get the answers. And then your homework, just make sure you ask, I'll post the homework for you. Thank you.